In the final episode of the camera system, I'm going to show you how to implement this camera system into a Pygame scene. So, as you can see, I'm still using Pygame version 1.9.6, and I'm not sure if this system or if this code will work with the upcoming Pygame release, which will be the 2.0. So I'm just going to show you the end result. Here we have a Pygame scene where we just rendering this floor, this monkey head, and also this rotating textured cube. And as you can see, I can move the view with the mouse, and also I can move around with the WASD keys. So we have the same scene what we had before, but now it is rendered inside a Pygame window. So I can press the escape key and the application quits. So the camera module, we are not going to change anything. It will stay as I wrote in the last 3 videos. And the only thing I'm going to change in the episode 18, I'm just added so this is the GLFW window. So I'm just added here in the keyboard key input callback checks for, so if the key is W and the action is pressed, I'm setting the forward to true, and if the key is W and the action is released, I'm setting the forward back to false. So for every keys. So this is the S key, this is the A key, and this is the D key. Previously I did everything in 1 or in 2 lines, so I'm commented out this line and added these checks, these elifs. So in this way the movement in the GLFW window is much smoother. So let's go back to the Pygame code. So the first thing, I'm just importing the OS module and I'm setting the environment variable SDL window or video window position to 400 and 200. So this makes the window appear always in the same position. So from the upper left corner 400 pixels to right and 200 pixels down. So then here are the necessary imports. So importing the Pygame from the OpenGL, the GL all, also importing the shaders, the peer model. From my texture loader I'm importing the load texture for Pygame. I'm just going to show you. So here I have now 2 functions. One is for use with GLFW and the second is for use with Pygame. So, and the only difference is that here in the Pygame version I'm using the pygame.image.load for loading the texture. I'm transforming, I'm flipping the image on the y-axis, also getting the image width and image height, and getting the raw image data using the pygame.image.toString image.rgba, and here I'm just setting the glText image 2D and returning the texture. So I'm also importing from my OBJ loader, the OBJ loader class, and from the camera I'm importing the camera, and here I'm creating a camera object, creating 2 variables, the width and the height, which will be the Windows width and the Windows height, so 1280 and 720, and the last x and last y will be the width divided by 2 and the height divided by 2. And also just creating here first mouse equals true. So here are the vertex shader and the fragment shader. Here nothing is changing, and I'm also created here a function called mouseLook. This is the same function I wrote for the GLFW window. Here it is. But in GLFW this is a callback function. In Pygame this is not a callback function, but this function will be called in the main application loop. But the body of this function is the same, so getting the first mouse, last X and the last Y, calculating if the mouse first enters the window, setting the last X and the last Y to X position and Y position, setting the first mouse to false. Then here calculating the X offset and the Y offset, and here setting last X to X position, last Y to last Y position, and calling from the camera module the camera that process mouse movement with the X offset and the Y offset, which just calls this function from the camera module process mouse movement, and the constraint pitch is set always just to true. So the next few lines I'm initializing the Pygame module with pygame.init. I'm setting the display to width and height, and also the flags to pygame.opengl, pygame.doublebuffering, and pygame.resizable. If you want to set a Pygame window full screen, here are another flag, you can set it pygame.fullscreen. I just commented this out, but I'm going to leave it here. The next two lines, I'm setting the mouse pointer visibility to false. So as you can see, as the application starts, the mouse pointer is invisible. And also setting the pygame.event.setGrab to true, which captures the mouse pointer inside the Pygame window. So if I comment out this line, which sets the visibility, now the pointer is visible, but as you can see it cannot leave the window, it just always inside the window. Okay, for now I'm just going to set the visibility, I'm just going to leave commented out this line because I still want to show you something later. So here I'm loading the three models, the cube, and the cube, for loading the cube I set the second arguments to false, so which means I'm going to draw the cube using GLDraw element. Then I'm loading the monkey and the floor. Here compiling the shaders from the vertex source and the fragment source, and I'm creating here a vertex array object, I mean 3 vertex array objects, 3 vertex buffer objects, and 1 EBO or element buffer object for the cube. So here are the settings for the cube VAO. Here are the settings for the monkey VAO, and here are the settings for the floor VAO. The only difference is in the cube, as you can see, I'm also setting the EBO or the GL element array buffer. And okay, now here are the textures. I'm creating 3 slots for the textures, and I'm using the load texture for Pygame, for the cube, here for the monkey, and here for the floor. Okay, here just telling OpenGL to use the shader program, setting the clear color, enabling the depth test, and also the blend and the GL blend func or function. Here I'm creating the projection matrix, perspective projection. Here I'm setting translations for the cube, translation matrix for the monkey, and a translation matrix for the floor. And here I'm just, although this line is not needed, so I'm just going to comment this out because the view is calculated in the application loop. So I'm just going to comment this out. So here is the model location from the vertex shader, and the projection location and the view location. here I'm setting the projection, and I'm just going to also comment out this line, because now the view is set inside the application loop. So okay, so we have usual Pygame stuff. So I'm creating a running equals true, and while the running is true, in the first, so this is the application loop. First I'm checking for the event, so for event in pygame.event.get. If the event type is pygame.quit, the running will be set to false. So which means if you click on this red X on the window, the running will be set to false. And if the event type is key down and the event.key is key escape, running will be also set to false. So because now the mouse pointer is captured inside the window, I cannot click on this red X on the top right. So that's why I had to set the escape keys to actually being able to exit the application. Here are just some code uncommented out. I'm just going to delete these two lines. And also here I'm checking for the video resize. So if the window is resized, I'm just going to set a new viewport with the event.width and the event.height, and recalculate the projection matrix with the new width and the new height, and also upload to the uniform location projection the new projection matrix. And here are the key presses. So you can get the key presses from Pygame using the key pressed equals pygame.key.getPressed. And if the key pressed Pygame key A, then I'm going to process the keyboard left with the velocity of 0.08. And here is the logic for the key D, and here is the logic for the key W, and here is the logic for the key S. So A moves left, D moves right, W moves forward, and S moves backward with the velocity of 0.08. So these few lines makes the WASD movement. So back, right, left, forward. You can also press down two keys, let's say the back and left, and it will move diagonally. And here we are checking for the mouse position using the pygame.mouse.getPosition, and setting the mouse look method. So the mouse look is here, this function, and the mouse look, as you can see, takes two arguments, the X position of the mouse and the Y position of the mouse. So let's go back to the application loop, and here for the mouse look I'm setting this returns a tuple with the mouse X and the Y position. So I'm just indexing it with mouse position at index 0 and mouse position at index 1. So this makes the mouse look script. I mean, this makes work the mouse look script. I'm added here also some logic for actually turning 360 degrees around. Without this, I'm just going to comment it out. Without this logic, I can only turn this amount, so until the mouse pointer reaches the left side of the screen. I cannot turn more than this degree. And also to the right, this is the maximum amount I can turn, because the mouse pointer reaches the right side of the screen and it cannot move further. And it also, for the top and the right, is the same. So with these few lines, what I tried to actually solve this little problem so that I can look around 360 degrees, although, as I stated here, it's still not perfect. So here I'm asking if the mouse position that 0 is less than or equal to 0, so at a 0th index, I'm just setting the pygame.mouse that set position, which sets the mouse cursor and pointer position, to 1279, so the window is 1280, and for the Y, the mouse position at index 1. And also, if the mouse position at 0, so which is the X position, is bigger than or equal to 1279, I'm setting the mouse position to 0 on X and mouse position at index 1 at Y. So this, although it's not perfect, I'm going to show you the problem. So this makes that if the cursor reaches the left side of the screen, it will just set its position, this logic will set its position to the right side. But there is a jump, a slight jump, as you can see. So now the cursor is on the, the mouse pointer is on the right side, so it jumped to the right side. And I can rotate the view 360 degree. But as I say, there is a slight jump, so just look at it. So now I'm reaching the right side and hops. So as I stated here, it is still not perfect. I'm just going to add back this mouse visibility to false, and here it is when it reaches the left side, and as you can see here is this jump. I had no idea how to solve this jump, so maybe later, or if someone of you knows a better solution, please write it down in the comment section. But now at least we have a working Pygame camera. Okay, and yeah, so we were here. And the usual stuff, I'm getting the current time using the pygame.time.getTicks and dividing this by 1000 to get the actual milliseconds, clearing the color buffer bit and the depth buffer bit, and then getting the view matrix from the camera module and setting the view matrix in the vertex shader using the GL Uniform Matrix 4FV. Also, here I created a rotation Y for the cube and the model matrix. So here are just drawing the cube using the GL draw elements. So remember that I say that the cube is loaded with the indices, and the draw the monkey with the GL draw arrays, and draw the floor also with the GL draw arrays. And here I'm just flipping the front and the back buffer. And of course, when we press the escape key, the pygame.quit will run lastly. So here I'm just going to show you one more thing. If you want to get the keyboard events from this for loop, I'm going to comment out these lines. The problem with this is it only checks once for the keyboard. So if the event the type is pygame.key down and the event that key is key A, so which is the left movement, I'm going to set the camera.process left with 0.05. I'm going to change it to 0.08, and I'm also going to show you what's the problem with this. So now if I'm pressing the A key and I'm holding down the A key, but nothing happens. I have to repeatedly press the A key to actually move to the left. That's why I commented out this. You know what? I'm also going to delete these lines and made this one. So this is constantly checking for the key, which keys hold down or which keys was pressed and hold down. So with this is the movement is much smoother. I'm also going to upload, of course, this. Oops, as you can saw, it was also a slight jump. This is because still the problem with the mouse. And I'm also going to upload this code to my GitHub repository, and the link will be in the video description.